Hello and welcome back to our videos. This series we are talking about setting up your scene graph in Ogre 3D. And so we've been doing some programming and we parented two nodes to each other. Basically, we parented a Sinbad node to the root of the scene, and then we parented a Ninja node to the Sinbad node. And I showed you a little bit about positioning these nodes with respect to one another. We already know how we can scale nodes and how we can translate them and how we can rotate them. We also talked about when you're performing transformations to a node, it goes through its children nodes as well. So, for example, when we scaled the Sinbad node up and down because the Ninja node was parented to it, that also got scaled up and down. Now, all of the transformations in Ogre 3D have a space at which these transformations may be applied. Namely, the three spaces that are important for us to consider and to know about are the parent space, or TS underscore parent. So TS basically stands for transformation system, and TS world and TS local. So what that means, for example, when you're performing an operation, a transformation, and transformations are scene node methods of rotate, position, yaw, pitch, and roll, and scale. So these transformations can happen in these three spaces. So for example, when we perform a translation transformation, move a node, we can specify, by default, it is at its parent. So by default, when you're performing a transformation, it goes and it's applied in the parent space mode. And then if you want it to be local to itself, you can use the TS underscore local as the second argument of your transformation. And if you wanted that transformation to happen with respect to the world space, then you would apply TS world, or rather as the global transformation space. Now, to show you what that means, let's take a look at what we have here. I created an example, and this example should basically show us effectively how these transformations are applied. Let me actually take a picture of this and show you in the sketchbook whiteboard how these transformations are applied. All right, so these are the agents basically or the nodes that I want to perform my transformations on. So let me set this scene up for you. So I have a scene node, and I call this the parent node. So think about this as, for example, my Sinbad, right? And then the way that I set its coordinate systems up, basically to show you what is its own coordinate system with respect to the world space. So if I were to look at my world space, kind of like from the negative z-axis, so we would have your x-axis, and then you would have your y-axis, and then your z-axis would basically go that way, right? So if this were my world space, I have my node to be positioned in such a way that, for example, I have the x-axis here, and then the y-axis here, and then the z pointing outwards. So if this were the coordinate system for my parent, and then I have the node, this blue node here, and let's say that its x-axis is basically the red axis pointing downwards and then the y-axis pointing upwards, that would be its own coordinate system locally. So I basically specifically made these so that they're kind of, rotated with respect to one another, because in the rotation we can actually explain this pretty well. And let's say the transformation that I want to apply is I want to move the blue node along a certain amount, or let's say along the y-axis. And obviously, you know that this is going to be node, and then set position. And then I'm going to pass to it a vector 3. And then I'm going to say 0 and some number like 100 and 0. Right? So what we have done so far, we have closed the parentheses here. Basically is when we use our default transformation space for us to transform. But if I wanted to specify which transformation space I want this transformation or this set position to apply, and basically this is basically like translate the node, or in other words, move it, right? So I can specify my space here. So I have the options of TS local, TS world, and TS parent. And this should be a good example of demonstrating what differences there are. So what when I'm specifying that I want to move this blue node along the y-axis, it is very important for the Ogre system, for my rendering engine, to know whose y-axis am I talking about. Is it the y-axis of my world? Is it the y-axis of itself? Or is it the y-axis of its parent? So when I want to move this node, I have actually 3 different ways of moving it. So these transform spaces actually specify that's exact, I guess, disambiguation of what you mean by move it along the y-axis. So when I say I want it to move along the y-axis with respect to the TS local, then that means that take your own y-axis and move yourself along your own y-axis 200 units. So this will be basically the TS local parameter will allow me to say that, oh, okay, the y-axis that you want to move along with, that would be this y-axis. The TS parent moves you in the parent space. What does that mean? That means that when you're moving 20 units, actually look and see which object, which node is your parent. Look at their axis, y-axis, and then move along that axis. So why would this be an interesting thing to do? For example, if you're shooting a bullet out of a gun, you want the bullet to go straight out of the gun as opposed to wherever its own orientation may be. Or its own coordinate system, maybe. So you would use something like this when you're creating particle systems and particle effects. The parent space would be very important for you, because if it's at the end of a jet and the jet is moving about, you want to be able to actually specify that you want these particles to go out of the back nozzles of your jet engine, and so forth. And the third coordinate system that's important also for us to be able to use, and sometimes we actually do use it, is the world space. So if I wanted to move this node just globally in the scene, and then I would specify that I want my transformation space to be TS world. And this will actually perform the transformation along the y-axis of the global scene. So it doesn't matter where my object is pointing towards, or where the parent of this object is pointing towards. The transformation will actually ignore all of those, and it's going to actually apply this globally. When would that be useful? Let's say that if you're creating a physics system, and then you have a ball that's kind of moving about. So its coordinate system is going around, but you want this to go up and down and up and down and up and down, and this is actually the global coordinate system. So you want this to go on the y-axis of the world as opposed to the y-axis of itself, which may be moving around kind of like this. So you don't want this ball that is dropping down, and you're creating this physics for it. You don't want it to use its own coordinate system. If it has something attached to it as a parent, you don't want to use that coordinate system, but you want to use the global coordinate system, and this is how you would use the global coordinate system, or rather the 3 different coordinate systems to specify the transformation that you want to apply to your objects, and specifically the scene nodes that we're talking about right here. Now, these scene nodes could be cameras, they could be lights, all sorts of things that obviously would parent to one another and will be able to perform the actions on. So with this quick overview of what our different transformation spaces are and what they mean, let's actually go in and experiment with them. All right, so here we are in our code. And so if you remember, we had create or placed a Ninja node and a Sinbad node, and we made the Sinbad node sort of parented to the the Ninja node parented to the Sinbad node, and we had the Ninja to turn around so that it would be facing the back of the Sinbad. So let me just rerun this. So we'll get a view of how it looks like, and then we're going to create a couple of these objects and nodes, and make them move about. All right. So first thing, you notice that the Sinbad is right in front of the camera, and Ninja is kind of right behind his left wrist. So it's kind of like sneaking that way. What I want to do, so that we would get a better kind of like above view, or rather the top view of this scene, I want you to think like when you are sitting and looking at this scene, and that's where the camera is. And the camera is fixed because I'm using the base application example, and I'm just overriding the create scene, which basically I can set things up in it, but I can't do anything to the camera. So I can't move the camera about. So what I want to do is I want to create a scene in which I'm looking at the top of the Ninja's head and Sinbad's head. Since I can't move the camera, I would have to move the Sinbad and the Ninja. The good news is that, or rather rotate them. So the good news is that the Ninja is parented to Sinbad. So if I rotate the Sinbad node, both the Ninja and the Sinbad would rotate. And the rotation that I would apply, let's see, I want them to be rotated along the x-axis. And if I'm remembering right, it's the pitch. So I'm going to set the pitch of Sinbad node to radians and half pi. So it would be math half pi. And so let's see how it looks like if we do this. All right, so now the Sinbad is rotated, so I'm now looking on the top of its head, but the cameras, or rather the Ninja, is far out of the view, so I won't be able to see it. So just press S and move outwards, and then you'll be able to see, or rather have the camera walk back from the scene, and you'll be able to see sometime about now, the Ninja should start showing up in the upper right corner of the screen. And it should be also rotated as well. So now you should see right about now Ninja is entering the scene. I'm walking out, basically. I'm walking backwards, making the camera move backwards. So that's actually quite a ways. So what I need to do is, first of all, for us to be able to fit the Sinbad and the Ninja in the screen, let's make the Ninja move forward, and then we'll move both the Ninja and Sinbad out. So I want to make the Ninja move forward. So right now the Ninja is about negative 30 units behind, or rather 30 units behind Sinbad. Let's make that, let's say 10 units behind Sinbad. And then also, since the camera is too close to this Ninja, to the Sinbad node, we're going to make that make the Sinbad node to walk away from the camera. So that would be adding another negative value to its set position. Vector 3. Now I want it to move on the z-axis from the camera, so let's move that by about 1,000. And let's see how far that gets us. All right, so that's pretty far, and it looks like my Sinbad moved, or my Ninja moved up front, which is the problem. placed positive 10 units. So let's make that negative 10 units. So the ninja is behind the Sinbad, actually. That's what I want to do. I want the ninja to be behind the Sinbad. And then when I get that set up, then I'll be able to kind of, I'm going to show you in terms of the parent space and the world space. That is okay, except that the ninja is out of the scene. You know, actually, let's make the camera move a little bit away more, or rather, let's just have the Sinbad move a little bit away. So let's make this 1,500 units. That should give us a pretty good, decent view of it. Okay, yeah, I think I can live with that. So right now, the ninja as the Sinbad node is in the center, and obviously since both objects were parented to one, I mean the ninja was parented to the Sinbad. When I rotated or pitched the Sinbad, the ninja also moved with it, and so both of them. I now have a top view of the scene. Although remember, I didn't do anything to the camera. I just moved the scene nodes and rotated them. So obviously, when I moved the ninja back and forth, it was in the ninja's, or rather the ninja's coordinate system. So to demonstrate the differences between coordinate systems, let's actually do two things. One is we are going to place 2 more ninjas, and then we are going to make those rotate so that their view is a little bit different from the Sinbad, and then we're going to make the movements on the 3 different coordinate systems. So let's get that going and set up. So first thing, we already have these other Sinbad nodes, and I think I like the Sinbad, so let's have everybody Sinbads. Actually, or let's actually swap. Let's make the ninja node the parent of everybody, and then the Sinbad node to be the child. So how can we do that? So let's go ahead and we are going to make the Sinbad node to be the child node of I want the Sinbad. Okay, so I want the ninja node to be the parent, and then the Sinbad to be the child. Because I have 3 Sinbads, and I can demonstrate every single one of those. So so then since I'm already scaling down this ninja, it also scales down my Sinbad, which then I'm going to go ahead and scale the Sinbad node up by a lot. So let's do it this way, 500 and 500. And then, so the set position of my ninja is at the location it was. So we're going to make this to be Sinbad node 1, and make the Sinbad node 1 to also rotate so that they would be looking at each other. And then we'll have the ninja node to pitch. And then set its position. And then we'll see if it looks like it's correct. If not, we'll just move modifications to it. And then we'll add the other 3 ninja nodes as well. I mean, Sinbad nodes as well. Okay, I think that I misspelled one of the nodes. Sinbad node, ninja skill. Sinbad node 1. Was the size too high? Okay, let me debug this error and see what the problem seems to be. No, let me show you actually the problem. I hope that you also did a little bit debugging. The problem was that I made the Sinbad node the child of two nodes, which is not allowable. Each node must have one parent, but one parent can have multiple child nodes. So I got to do the Ninja node actually in here when I actually set the scene up. And I probably should have set this up down here with everybody else when I was setting up the scene, basically. So I'm actually adding Sinbad node to the child as a child of root, and then I'm having it also be attached as a Ninja node that doesn't have a parent. So I got to actually do the Ninja node to be the child of root, and then have the Sinbad node, so I create and attach stuff to it, and then have the Sinbad node to be the child of the Ninja node. So I have the root, then I have Ninja, and then I have Sinbad. Well, that was kind of embarrassing. I totally forgot about the origin. So let's rerun this code, and hopefully this fixes this problem. But I'm glad we encountered this problem. It is actually important for us to see. Okay, perfect. So I have the Ninja node as the parent, and then Sinbad as its child. So let's go about and do a little bit of cleaning up here. So I have Ninja node created, and then I attach the object to it, then set its scale to half, and then made the Sinbad to scale up. Actually, let's comment these. So we'll set the whole thing up from scratch again. So Ninja has a child Sinbad node. Sinbad has Sinbad attached, and Sinbad is scaled up. Let's see how that looks. All right, so this is pretty good. So this is where we start. So Sinbad and Ninja are effectively created, and the Sinbad node is the child of the Ninja, and I'm going to make the Ninja node smaller. Let's make this 0.1. I should have kept the original values, but we can experiment with these some more. All right, so this looks good. So now I have the Ninja at a kind of small scale, which is pretty nice. And then I'm going to make the Sinbad scale up so that they would be almost the same size. What about my Ninja? Did I scale it too high? Let's make it 10. Okay. I think they should be okay. So maybe we'll do 15. And I'm going to scale the Ninja up, and that scales up everybody. Okay, yeah, the Ninja and the Sinbad are pretty much scaled to each other's sizes. And then let's make these, actually let's go with original scale. Maybe it doesn't want to get the scale 1, okay? So just comment that out. Okay, I think this looks pretty fine. We will then move the Sinbad upwards. So set position, and it would be, for set position, let's just not use vector 3. So we say, I want it to go up at, I don't know, maybe 10 units, and we'll see if that's 20 units, and then 0. I'll see if that is too much or too little. We'll fix that. Yep, Sinbad, not Sinband. Sinbad node. Okay, now recompile. I misspelled Sinbad a few seconds ago, so I fixed that. So we have the scale of the Sinbad 15, which kind of makes it the same size as Ninja, roughly. And now I'll move to the Sinbad 20 units upwards along its y-axis. Was too small. Is 100 going to be enough? Probably should have made my measurements, but well, it's a good experience anyway. I think it's all right. We will scale Sinbad up a little bit until it reaches the same height. So I'm guessing maybe 20 would be a good scale. Yep, now the two objects are almost the same size, which is actually kind of nice. So now let's go ahead and move this Sinbad node to the right, and then we'll add another Sinbad node to the left, and another Sinbad node to be behind. Before we actually do that, let's also rotate this Sinbad node, and that should be fairly straightforward. So we do Sinbad node 1, and we make this to be along the along the y-axis. So I want to change the yaw to be 90 degrees. Radian math half pi. Okay, and then I'm going to reuse these numbers again for the other nodes when I'm attaching those things. Half pi was 90 degrees. I want a full pi, so yeah. So that the Ninja and the Sinbad are actually looking at the same direction. This looks pretty fantastic. Now let's move the Sinbad to the right. And that should be easy. We need to add some X to it, so maybe about 50 units. We'll see if that is enough. Okay, 50 was too small. 100 should be plenty. Now let's make it 150. I meant 150, not 105. Okay, yeah, this is good. I think I like this this distance between the objects. Okay, now let's move everybody to the right so that you would be able to fit two Sinbads on the left of the Sinbad, I mean the Ninja. So how about moving everybody by about 50 points? So since I want to move everybody by 50 points, I'm going to go ahead and move the Ninja node because it's the parent. So the Ninja object is rooted there. So I'm going to go here and I'm going to do Ninja node set position to 50 units on the right and still to be at the center. That's about right. And that might make the Sinbad a little bit off the screen, but that's fine because we're going to rotate everybody down and move everybody downwards anyway. Okay, yeah, this is actually perfect. Then we'll do two Sinbad nodes. And the good news is that we already have these two Sinbad nodes already here. So Sinbad node 2, which we created here. And we have the entity for it and the attached to object. Now I'm going to bring everybody up, Sinbad node 2 and 3. So let's place them here and see which ones we need, and we recycle them. So I already have Sinbad node 1 and 2 and 3 created, so I don't need those. Do I have entities for them? I don't. So let's bring in the entity for Sinbad node 2 and the entity for Sinbad node 3. And then right now they're actually added as child of root scene manager, I would like to make them as child of the Ninja node. So that's actually easy to do. So Ninja node, add child Sinbad node 2, and then Ninja node, add child Sinbad node 3. Let's move these guys also upwards. So I'm adding all the 3 Ninja Sinbad nodes to the Ninja node, and then I'm going to also go ahead and add, or rather attach, the 3 Sinbad entities to their appropriate ninjas. Now, since I already have done the movements and rotations for Sinbad node 1, I'm going to replicate these, one for Sinbad node 2 and one for Sinbad node 3. So the yaw will stay the same for the 3 of them, because all of them are going to be looking at me, at the camera. I want them to look backwards. So all the yaw for the 3 of them will be 50 points. The scale would be the same. I want the Sinbad nodes to have the same height, or the Sinbads to have the same height. The positions would be different. So one of the positions would be negative 50 units, or rather how much? Negative 150 units from its root, and which would be your ninja. So one Sinbad node 1 is 150 units to its right. I want Sinbad node 2 to be 150 units to its left, and I want Sinbad node 3 to be 150 units to Sinbad node 2's side, which means that it would be 300 units from the Ninja node. And obviously you would want them to be Ninja node 2, and then, or rather Sinbad node 2 and Sinbad node 3. I don't know, I just give them names like that, but that's the way it is. So let's actually go to the sketchbook drawing. So here's what I want to have, and we'll see if I succeeded at creating it. So I have my ninja here, and then I want the Sinbad 1 to be 150 units to its right, and I'm going to just create little horns for it. And so then I want the Sinbad 2, and it's actually kind of beefy, so to be 150 units to its left. So this is Ninja, and this is my Sinbad 1. This is my Sinbad 2, and then Sinbad 3 would be negative 300 units. And remember, these are all the x-axes, and these are the y-axes that way, right? So, and obviously this is what I called Sinbad 3. All right, so that's set up. Let's compile and see if it does compile. Now, if it does compile for us, then we should be able to see, and it did compile, we should be able to see Ninja node, and then one Sinbad to its right, and then two Sinbads to its left, and kind of at the same distance placed, which is exactly what I wanted to achieve. So now that we have this set up, I want everybody to be rotated. So so my camera is looking at the top of their heads. And that's actually kind of easy to do as well. Let's see. So you think about it. Which should I do? Pitch, yaw, or roll? I'll let you think about it for a second. And to which node should I apply it? Now, if you don't want to see the answer and you want to do it yourself, go ahead and pause the video and then do the rotations. And if you do want the answer, here is the spoiler alert. I'm going to use the Ninja node because it's the parent of everybody. And then I'm going to set its pitch to radian. And it would be math half pi. If it actually rotates them, so we're looking at the back of their feet, then we're going to rotate it the other way around. Okay, no, we are looking at the top of their heads, which is exactly what we want to do. So now we are kind of a little bit too close to these guys. So what I want us to be able to do is to move out so that we would get kind of like this view on them. And also let's move the Sinbad node 2 a little bit more to the left so that their hands don't, so that they're not holding hands. Not that there's anything wrong with that. So we are going to go ahead and make the Sinbad node 2 to go 400 units to the left, and then make the Ninja node set position. Actually, I already have a set position for Ninja node up here. So set position is 50 units, and I want them to go away from the camera, so that would mean a negative z-axis. And then we compile and run, and we'll see what happens. Okay, this is actually pretty good. So then let's also make the... So now we are good. We have the Ninja node as the parent node in the middle, and then we have the three Sinbads, Sinbad node 1 to the right, and then Sinbad node 2 and 3 to the left of the Ninja. And these are all parented to the Ninja node. So if I want to move everybody in the same line over, one way to do that is basically, as we have done so far, is to move the Ninja. So we would set position of the Ninja and we move its y-axis to go up, and it would move everybody upwards. So let's do that. See, I already have the set position for Ninja node up here on line 36. So if I add like 100 to the y-axis of the Ninja, then the Ninja and the three Sinbads all will move upwards with it. Okay, so yeah, they were in the middle. Now they're almost a third up to the top of the scene. So that's if I wanted to move if you move a node, it'll move all of its child nodes with it as well. So basically, that transformation is going to apply to all the nodes within their parent space, which is the space of the Ninja node here. So I set that to 0, so that we'll have some more space to work with. I'm going to rerun that so you see the difference between the Ninjas, the Sinbad and Ninjas. Now you see that all three of these actors are actually in the middle of the screen. So now let's take a look at the middle Ninja, Ninja 2. The middle Sinbad 2, the one that's immediately to the left of the Ninja. And let's make that node walk away, rather on the y-axis. And I'm going to make that to be along its parent node. But before I do that, I'm going to actually make it move or rotate it a little bit. So that it is... So now here, let's do the comment. Now we will test the spaces. Transform spaces. So let's take Ninja node 2 and rotate. Sinbad node 2. Sinbad 2. 45 degrees. So Sinbad node 2. I'm going to take it. And then, so I have, now this is a little tricky. I want it to run along its z-axis. So let's actually experiment with it. So we will do the roll of it for degree 45. And let's see which direction it moved. And the reason that I'm rotating it so that I could give you the difference between the parent space and the local space. Okay, roll wasn't what I was looking for. Then let's try the pitch. No, not for the yaw. Of the Sinbad. I'm sorry, I changed the yaw of your ninja. I want to do the pitch of the Sinbad. Yeah, that's what I want to do. Okay then. Let's say I moved too many rotations. Rotation can tend to get tricky. So I want the pitch. What was it? Was it pitch? Or I want to change the roll. I want to change the. Yeah, I usually do this trial and error. This is one or the other. There we go. Okay, so the Sinbad node is kind of now looking 45 degrees to the left. We're going to make the Sinbad node 1, which is the one to the right of the ninja, to be negative 45 degrees. So it's going to look the other way around. And then I'm going to have the Sinbad node 3 to actually look straight up. Fantastic. So this should set up really well in terms of getting a good overview of what is it that's going on with the world space, parent space, and local space of transformations. So let's suppose that we want to move the ninjas along their z-axis. Let's test that out. What happens if I take ninja 1 and set or Sinbad 1 and set its position 0, 0, and 100 units on its x-axis or its z-axis. The set position set the relative location of your node with relative to its parents. So basically, whenever you wear on to the right of your parent, when you set the position, it's going to move you behind on the z-axis of your parent. So it's going to place you behind the location of the parent. And so here you see the z-axis of the parent is the axis of the parent of the Sinbad is the axis that goes through the ninja. Kind of like, you know, we're looking from top of the ninja node. So its z-axis is the axis that is its forward direction, basically the direction of the sword. That's what I mean. So what I did is when I set the position of the Sinbad to 0, 0, negative 50, it basically took the Sinbad from the right of my ninja and it placed it 50 units behind the ninja. So if you look at the set position of Sinbad node 1, it is basically at, where have I placed it? Sinbad node 1 is at 150 units on the x-axis, and then 100 units on the y-axis, and 0 unit on the z-axis. So when I move at 100 unit on the z-axis, then it's going to basically place it behind. So what if I want to actually translate my Sinbad in different coordinate systems? So that operation is basically done through translate method. There are actually 4 overrides for the translate method. You can give the translate method basically a vector 3, which is your displacement vector, and that is how much on x, y, and z axes you want to move along, and then give it a coordinate system that you want to move along with that coordinate system. And that's exactly what we talked about earlier at the beginning of this lecture unit. So the coordinate systems that you can do by default is TS parent. So when you translate by some vector, then that would translate you with respect to your parent. The other options are TS local, which is with respect to your own transformation system, or TS world, which would be with respect to the global coordinate system. So let's translate our ninja by 0, 0, and 100. And this is actually a vector 3. And then let's do TS local, which is basically node TS local. Okay, so the Sinbad was to the right of my ninja, and I moved it along the z-axis. And z-axis, you can think of it as the forward vector of my my Sinbad. So when I move the Sinbad, with how much did I move? By 100 unit on TS local, that means along its z-axis. Let's see what happens if we do it along the axes of parent. So let's take Sinbad 2 and move it, or Sinbad node 2 and move it with the same amount, 100 units, but this time let's do it with TS parent. Okay, so with respect to TS parent, when I apply my transformation, since I'm using a positive value, so I'm saying I want to move 100 units along the positive z-axis, and I want that to be in the parent location or the parent coordinate system. Remember, the parent coordinate system that we had for the ninja was the opposite of the Sinbad. If you remember, Sinbad and ninja were kind of looking at opposite directions when we replaced them. So I actually had the Sinbad rotate backwards. And so when I actually say I want you to go by 50 or 100 units positive on the z-axis, that means that you want to move backwards on your coordinate system of your parent, which is the ninja coordinate system. So that's why when I applied 100 unit, it actually moved my Sinbad backwards. So let's actually do this, I don't know, like a larger amount, kind of like 250 and 300 in the local coordinate and the parent coordinate systems. It actually see much more magnified shifts on the space. Okay, so now you see the amount of transformations that I did for Sinbad 1, the one on the right, is on the local coordinate system. So the z-axis actually moved it along its forward direction. For the Sinbad 2, which is the second Sinbad, actually the first one on the left of Ninja, I moved it along the z-axis, but the z-axis of the parent. And the parent is the Ninja node, so I actually, although the direction of the Sinbad is different, it's actually moving it along its parent axis, so it goes up and down the z-axis of parent, whereas the z-axis of the Sinbad 1 is kind of diagonal. So let's make the third Sinbad, which is the leftmost one, let's make that go by about, I don't know, again, 300 units. But this time, let's make it world. And at this time, I'm gonna move the direction or translate my my Sinbad 300 units or negative 300 units, but this time not with the z-axis of the Sinbad itself or the z-axis of its parent, but rather with the actual global z-axis of the world. And the global z-axis of the world, if you think about it, is the vector, is the axis that's pointing outwards from the screen. So when you move that Sinbad, or rather actually move the wrong Sinbad. So move Sinbad node 3 and translate in 300 units along the z-axis of the world. That would be the vertical axis that's pointing out of your monitor. So the third Sinbad should look smaller to us because that is actually moving that node away from the camera in the world coordinate system. So with 300 units, it would be almost the same location as it were before because we didn't move it on the X and Y axis. But since we're moving it away from the camera, you see that the Sinbad looks smaller. And so to show you exactly what I mean, if we get closer, you would see that this Sinbad This one has moved away from the camera, which is the z-axis of the world coordinate system. And then this is my parent. And so the Sinbad node 2, which I moved along the z-axis of the parent, it actually moved vertically up because the z-axis of the parent is vertically up. Remember, we used the pitch to move the Ninja around. And finally, the Sinbad node 1, which I moved it or translated it along its local coordinate system, it moved diagonally. So the z-axis of itself was diagonally with respect to, which was 45 degrees, which we set at these angles here, -45 and +45. So the local z-axis is 45 degrees diagonal. So the first Sinbad moved diagonally. The z-axis of parent is vertical. So the second Sinbad, which we moved along the z-axis of its parent, goes upwards, goes vertically up on the screen. And then the z-axis of the world is pointing towards us. And we moved the third Sinbad -300 units, which pushed the third Sinbad out from our view. So that makes the third Sinbad to look smaller. Actually, to make this a little bit more visible, let's make this actually 1,500 units. So now that Sinbad 3 should go way away from the camera. So we should on the z-axis, so we should see it very, very small. Okay, and that's what you see. The third Sinbad, it goes all the way down because it goes on the vertical axis, or rather the z-axis of the world. So this is the transformations that you can perform on your scene nodes in Ogre in the three spaces: the world space, the parent space, and the local coordinate space, and how you can actually build scene nodes and scene graphs a little bit more cleverly to take into account the hierarchical relationships of different objects with respect to each other. Bullets with respect to a gun with respect to the actor that's holding the gun, and all the scenes with respect to the world where they are placed. So with this, I'm going to wrap this video up. It's going to be probably a little bit longer than the usual, but it should give you a good sense of how different coordinate systems are applied and what scene graphs are in Ogre and how you can build a scene and render it properly with its different building blocks and components. And this would be very essential for you if you were to actually build a game in Ogre. So, so this is basically the end of this portion of the lecture video. In the next lecture video, I'm going to start talking about lights and shadows in the Ogre engine.